All right. Well, hello, everyone. Thank you for taking a look at our Kaufman Engineers Spokane Industrial Roadshow presentation. Appreciate your time. And purpose of this presentation is to go through some industrial projects that we have worked on in the past and some of the tools that we use and how that might be of use for you guys in the future. A little bit more information about Kaufman Engineers. Been around for about 42 years, multidiscipline, 500 plus employees, over 11 offices spread out through the U.S. And Hawaii and Guam. This is our Spokane Industrial Leadership Team. Myself, Matt Hebert, Principal Mechanical Engineering. Jeff Mitchell is a principal in our structural group and our structural lead for industrial projects. Luke Bergeron, mechanical principal, specializing in oil and gas. I'll get back to Cully Paris, who's presenting with me here in a moment. Mark Sight, senior discipline engineer, specializing in boilers and steams projects. Joe Corris is our lead electrical engineer, and Phil Pintor is our senior principal mechanical engineer. Back to Cully Paris, he's our senior discipline mechanical engineer, emphasizing projects on FEA and machine design. And take it away, Cully.
Yeah, glad to be here with you, Matt. Thanks for the introduction and everybody on the horn here checking out the presentation. We're just appreciative of a chance to introduce ourselves. The reason we're doing this is we want to be able to say yes to our clients, and we want our clients to realize how many things we can say yes to. We want those out-of-the-norm problems that you might struggle with internally for whatever reason that is. Sometimes it is a client that requires a second view by another engineer. Sometimes it's that you see risk and you're concerned about that risk. We want to do that both for our internal departments. We often work for other disciplines within Kaufman and other offices, and then we often work for other clients and help to reduce their risk. Ultimately, what we're doing is we're leveraging these investments that we've made over time to ensure that we keep those skills that we've developed sharp, and that we utilize these specialized software tools that we have developed skill with, and that we're investing in by monetarily maintaining their licenses. This is the kind of picture of what we're talking about. We want this sort of thing to not happen to our clients. This is a machine that a client of ours designed through kind of poor QA/QC and improper modeling practices. The model that was used to develop this design failed to show that there was going to be a problematic buckling strength issue with the way that this machine was designed, and we came in after the fact and helped our client to rapidly fix the problem. And we also did an analysis and evaluation of a number of other designs and identified challenges with those. In some cases, we were able to avoid kind of an in-place problem like this from happening again when it probably would have. So the overview of our presentation today, we'll jump back and forth between Matt and myself as we highlight some specialized tools. We introduce you to what our industrial focus areas are, and interspersed with that, we'll point out some example projects that highlight the way that works. And hopefully throughout the whole thing, you're just seeing different ways that Kaufman and your company can join up, that we can support one another, possibly team, and in the end, just make sure that you understand how we can be of service to you. There's a quick example. We'll actually go into this over the next few slides a little bit more, but specialized construction applications, sort of unusual. You know, we used this crane, but we didn't use the crane itself. We took the boom off and made this thing very, very short and stubby. Its primary purpose was just to help haul something up and down the face of an earthen dam where there was really poor access and no way to get debris and construction materials down to the area of construction. and we worked with the contractor together to develop this. It was actually on the same project that we teamed with a large engineering outfit to support their proposal on this project in response to an RFP. And we developed this model here, just a real simple model that we developed using data that was provided with the RFP to demonstrate what our capabilities were to the potential client that we were teaming together. And so we wanted to be able to show this in response to the RFP and show how we might approach the problem. And a little challenge with that slide there, sorry about that. But we could see we identified how we were going to resolve their problem, which in this case was utilizing a floating platform with an intake that had a variable elevation in order to allow water to be pulled from a specific elevation within the pool above a dam, and that would allow the control of the temperature of the water being discharged on the downstream side for the purposes of fish environment. We designed a custom swivel joint in a previous project. We felt that was a good application for this. So everything you're looking at here is how we helped our client chase after an RFP and ultimately win that RFP. And then ultimately, in the course of walking the site, once we had been awarded it, we walked out here and we started talking to the client about, what is this? And we realized that the solution that we had come up with before, there was actually a selective water intake that existed. It's a bypass to another dam, but we realized we could actually drill a hole through the hill and tap into that water supply. And so in this case, we designed ourselves out of most of our scope, but the client was given the best solution, and the engineering firm we were teaming with really what looked good in the middle of all this, and were able to supply their client with the best solution. So that's just what we like to do, is make things work.
And then on to some other multidiscipline services. These are just some examples that we'll go through. Structure modifications for pre-engineered buildings, construction access, construction engineering, engineered lifts, and forensics. So with pre-engineered metal buildings, one example that we're going to show here is Hughes Marine, which is a boat supply manufacturer in Washington State. They had a pre-engineered metal building that was not originally designed for cranes, and they were looking to install new 5-ton cranes. And the problem with pre-engineered metal buildings is there's no reserve capacity or excess capacity in the design. They're very simplistic in nature. And so our approach to this project was to consult with our client and offer up solutions to reinforce the columns. You can see on the left there's a dark plate running the height there, and then runs up to a corbel, and that's where the crane rail was installed. So that's one example of kind of a unique application. Construction access. This is a big one that clients come to us with on just how do we perform the work. An example here on the left is a bulkhead caisson at Lower Granite Dam in central Washington. And this was lowered into a gate slot and then jacked against rubber seals, thank you. Can't get the word out there. And then dewatered to provide access, and the reason why they needed access there was they were putting in a new fish flume or fish bypass system. Another part of this project is on the right there is a modular drilling platform, so it was built in 30-foot sections, 90 feet in total length, and a drilling rig was placed on top to drill 5-foot holes into the bedrock to support the fish flume downstream.
So this was an exciting project that we worked together on a number of years ago, and it was a large floating platform that was actually a construction aid for Round Butte Dam. And so this isn't part of the permanent installation, but in order to achieve the final installation, they needed tremendous lift capacity with good accuracy right over the water. And so this was a construction aid. And we validated the design using a combination of traditional structural tools and then finite element analysis on the pontoons themselves. They were relatively thin-walled and had pretty large punching loads being delivered down to them from the platform, especially below these truss towers. You can see it in action here where it was actually installed, and it achieved the intended purpose. It did it as efficiently as we could, and it did it safely. We knew that it was going to be safe because we had checked and validated that design.
Another sample is below the hook lifting devices, or BTH. The image on the left is a gate hoist at Rock Island Dam in central Washington. It's 250 ton. And then the picture on the right is a aluminum factory here in Spokane, Washington. And the unique part about this is that the pick was of an armature that used two different cranes that had two different capacities. So we designed a customized lifting beam that distributed the load properly. And then we also performed an engineered lift on this system as both cranes were exceeded their 125% capacity in this particular lift.
We get into thinking about why failures have occurred, and that can include looking at the material that the crane, let's say in this case crane girder, is made out of, or perhaps the weld procedure, where that welding occurred, and really to get at what the root cause was and what an appropriate repair procedure might be, whether it is a bolted-on fix after the fact or specific weld procedures to use to minimize residual stress and the chances of something like this repeating.
And then some other unique markets that we get into, the grain industry, new and existing silo repairs or designs, OSHA code investigations, fall protection. Obviously, that's a big thing right now that we're capable of. Cast in place municipal concrete water tanks, hydropower, fish bypass systems, and then mining and material handling. And we'll get into some other examples here.
So some of the specialized tools that we mentioned we'd be bringing up, 3D modeling that is joined up with scanning, and got a good example of that further down, and piping analyses, really crossing a number of different related areas of the piping, and more advanced finite element analysis, structural analysis programs, and Revit modeling that is multidisciplinary and allows great coordination for machine installations and manufacturing plants, things like that. So speaking of oil and gas, process piping, we do a fair amount of this. We've got a whole section of our industrial department that is dedicated to that kind of work. And like we said, Luke Bergeron is the head of that. He's just had really great success. It's been a thrill to be along and part of that. I've supported projects here and there with finite element analysis, and those projects include things like natural gas, liquid fuels, and process piping and steam within compressor plants and other types of facilities. Here's an example of taking some of these specialized tools. On the right, you've got a scan that was taken. This is a point cloud here, and you're seeing the model piping that's our modification installed together with the existing, so that we can coordinate and see maybe where things are gonna hit each other, where can we support piping, etc. And then pretty advanced piping packages for 3D design. When you're talking about more complex piping, sometimes it becomes very impractical to design in 2D. We also use pipe flow analysis for both compressible and incompressible fluid flows. You're seeing a couple of larger networks that we've done. We've done as large as a campus steam distribution system and as small as a couple turns with a pipe and a nozzle at the end. When you put in piping, you also have to think about the stress that the piping itself undergoes. That can be due to seismic or thermal ranges, and We use Caesar 2 and AutoPipe to perform that type of analysis. And then we can take that output and combine it with an FEA of, say, a specialized mount that has to be designed that you can't pull off the shelf, so to speak. And there's an example of one on the right. Just wanted to highlight a small process piping example. We did incompressible fluid flow analysis on this whole pipe path. Figured out how much energy we were going to have to disperse. This is water from the top of a dam feeding an experimental fish trap, and so we designed all of this custom and actually installed it, and it's been being tested for several years now. So that's just an example of how we can bring all these tools together into a cohesive and synergistic design that really takes advantage of these tools without wasting time. And there you can see an in construction image there at the top portion. So another example that we'd like to point out, here we have a connection. This connection is splitting because the model that our client put together and created was set up improperly. So what I would say is they had too much risk for the type of tool that they were using and not enough experience. And Kaufman has been using these tools extensively, and therefore have found that we can help avoid those types of risks. You could tell also there was a structural design issue here. Somehow somebody thought that one side of the flange could be a different thickness than the other side. That doesn't make much sense from a physics standpoint, but even without that problem, the primary issue here was that there was a huge moment in this beam that the client was missing. And we jumped in on site and helped to resolve resolve that problem and do analysis of other machines. Here's an example of one of those machines. We did reset analysis of the top portion of the frame. You're seeing the results of that analysis on the left. And then we took some of those outputs and checked highly stressed connections against custom bolt-up connections to make sure that they could survive. And then we took the loads from the bottom and we did this car body and did an analysis on the car body to see its deformed shape and where highest stresses might occur, and to validate that the design was effective and adjust plate thicknesses and that sort of thing as needed. So we also take these tools and support large manufacturing installations. We've done this in a number of cases. Got a great example here of a building that's housing a stretcher as well as a lot of other related process equipment. And we had to think about existing utilities, the modification of those utilities, how to phase construction for existing work to go on, how to incorporate the OEM equipment, and to combine the remodel together with new construction. And you can see here, this is one of our 3D scans of one of the large pieces of existing equipment that we were doing coordination with. We were designing some platforms that they could work off of that had to fit inside of the envelope of other portions of the machine that are already in place. And there you can see the physical Revit model that exists, which was a part of what we use. This is existing platforming, the existing machine in a similar position. So really it helped our client to visualize what we were proposing and for us to coordinate a design that worked well with what was already there. So we've got a video here of that Revit model, and this is already a phased model. Portions of the buildings have been removed. You can see down below there are utilities that have been incorporated into the model, and we had to think hard about those utilities and how to phase them in and get around the pits that we were having to install and that kind of thing. This is also a great way for our client to visualize just what their project might look like when you get inside. And so that's what I'm doing here now in this video is navigating into a location where you can kind of get a sense for how you walk through. Now the graphics take a second to update, so when you stop moving, they update and the client can see, oh, so now what does it look like if I move up to here? And so it move from point to point and get a good idea of how the equipment is going to interface with the building, with the foundations, with columns, with cranes and that sort of thing. And then we can use those to create 2D drawings, 2D construction drawings that the contractor can use.
Now we get into some of the specialty projects that we've done over the years. They range from general machine design, hydropower and flow management of gates, with gates, cranes and maintenance travelers, custom one-off projects, structural, mechanical gangways, access platforms, elevators. That example of that would be a passenger loading system onto a cruise ship. Multidisciplinary advanced Revit modeling, like Kelly talked about earlier, and then emergency support and construction services.
Yeah, we really pride ourselves on trying to be available to our clients right when they have emergencies, and making sure that they get what they need as soon as they need it. We've already touched on some of these things here, but we worked on mining trucks like you see in this image here, specifically the beds themselves, and doing analysis on how they're supported and the structural integrity of the bed itself and the way it's supported.
Another one of our big focuses is cranes. Some of our clients are Corps of Engineers, Bureau of Local PUDs, not only rehabilitation, but new construction as well. We do owner's rep and contractor design support services, and then the various types of cranes, bridge cranes, gantry cranes, and then modifications of those as well.
And those could be really cool, sort of custom design cranes where you can't just grab something easily off the shelf. Maybe there's an offset lift or something like that.
Right, and that previous picture that you saw there was of obviously the original design, and this is the updated design for a client here in Washington State. And then here's a rendering of the trolley system. This was a 250-ton crane that was used in tandem with a second crane to lift 500 ton. And then here's the crane picking one of the rotor blades you see there on the bottom right. Maintenance travelers is a relatively new industry that we've gotten into. This is a picture, obviously, of Golden Gate Bridge. We're designing 16 new maintenance travelers that'll run inside, underneath, and along the side of the bridge that'll provide maintenance access and then investigative abilities after a seismic event. This is a elevator at a hotel in Hawaii. So the elevator is kind of tucked into the building there, telescopes out, in and out to provide access to the windows down below. So we did a rehabilitation of this system about 2 years ago. This is a smaller bridge traveler here in Spokane, Washington. It's actually a unique little system. It's gas powered. You can just take the motor off whenever you need to for safety reasons, and it provides maintenance access to the bridge span. Hydrogates, similar clients to cranes, rehabilitation and new design, assessments of gate hoist systems, and then obviously spillway navigation, radial, and gate valves as well. This is a picture at Box Canyon Dam. This was a hydraulic hoist, so you see the HPU buildings there up on the piers, and then there's hydraulic rods, 30-foot rods that attach to the lower part of the gate for water spillage. This
is another area where we supported a contractor. The Corps of Engineers had done the basic design of the gate, but had never considered how the gate might be lifted, how it would be transported horizontally, and if you could safely, without overstressing it, move it from that horizontal position to the vertical position, because of course it was fabricated in the horizontal position. And so Kaufman performed a detailed analysis using a shell model and SolidWorks simulation for this entire 104-foot tall gate. And we ended up designing in a modification. These beams you see in here are the modification together with these custom lifting points up here. And we were able to demonstrate safe lifting of this gate and to perform that lift.
This was a maintenance access project at Lookout Point in Oregon. This is just another example of how we can work with the contractor to provide safe working environments. And then this is a picture of Rock Island Dam in central Washington. This is the 250-ton gate hoist that we looked at earlier. And again, the rendering of that system. And then some custom one-off projects. This was a fun one that we got to work on. This is a tourist elevator at Grand Coulee Dam. It runs up the face of the dam at a 45-degree angle. It was built back in the 70s and has been decommissioned since the 90s. We provided a phase 1 assessment for the upgrade of that project, and hopefully that moves to construction here in the future. This is a radial crane at a electron accelerator facility in Virginia.
Do those every day, right?
Again, we provided a phase 1 assessment and then wrote the project specs and drawings for the rehabilitation of this crane. The problem that they were having with this crane was that the rails from the beginning were not installed at the perfect radius, so they were getting some significant thrust loads at the wheels and were having excessive bearing wear. So we designed a custom slide design system for the trolley to be able to compensate for the out of roundness, I guess you'd call it, in the rail system. We did again a phase 1 conceptual design for the Space Needle group. It was a construction lift platform. You can see the platform installed at the top underneath the top house. This was for a client that was pursuing the construction portion of the project. They did end up using a variation of this, but that was a fun project to work on.
And we developed that whole model right there that you see using existing drawings and scans where the drawings were inadequate.
Right.
This is a picture of a snow hauler that we supported the design of and basically developed from the ground up, with the exception of these large wheel sets were purchased components that we then combined with our custom design. We did finite element analysis of the snow hauler. It's a dump bed, so it uses hydraulics to push up the sides there and just belly dump and then drive over the pile that it's left behind. Pretty interesting project. It had specialty requirements related to the low temperature that the steel would face, so some unique challenges there. And this was early on in our use of SOLIDWORKS simulation. We've gained a lot of knowledge since then, but the design has stood the test of time.
This was again, I mentioned gangway systems earlier. This is a passenger gangway system for Carnival Cruise Lines in Long Beach, California. We did the mechanical systems for this, and the unique aspect of this is that the platforms actually move up and down with the tide while the ship is docked, and then has some safety features for breakaway assist and things of that nature, but that was a fun project as well. And here you can see a close-up of the mechanical systems. In the far background there, you can see the jack screw. It's got the boot on it right there, but so you can't see the screw portion, but that's the jack screw that moves up and down. And then this was a fold-out platform to provide access for the passengers.
So emergency support, we've been helping out clients for a long time doing this, and we needed in this case to provide emergency support for a damaged component on the high side of the dam, 160 feet deep, and we needed to do that without welding. The reason being, it was going to be really difficult to do that welding at those depths. And here you've got a CAD that you can see of it. The original design involved the bending of a large HDPE pipe over the entire range of usage. It had some swiveling ability, but then when you got past that swivel, the pipe itself would bend. And an accident involving the support of the heavy end of this intake screen had caused the intake screen to fall without support, and it weighs 10,000 pounds. Even underwater, that's too much load with this kind of moment there, and it wrenched right off the face of the dam. So we got a little video here. We were able to see the condition of that connection down low. Obviously, we're joined up with a contractor here who had pulled in the support, and you can kind of hear the diver. His voice is all whacked out because the pressure is so high. And the point is, we were able to determine a new solution that did not involve a bending of this pipe. So we were able to take the load out of this connection and design a new swiveling joint, which could be assembled below the surface by divers and not put them at risk and be robust. And that's been operating to this day. We were able to, in the shop, we performed some calculations ahead of time to figure out how much load we thought would be required to rotate this thing, because we wanted to make sure that the way it was installed, the joint could freely rotate, but it was still pulled. And so you can see right at the torque that we had predicted, he's able to get it to move without snapping that torque wrench. And so that was a confirmation that we had a properly assembled component. And then on the top side of this, we also improved the guidance mechanisms and the way that the platform that supports that intake screen rides along the face of the dam, designing this custom caster set that you can imagine improving with the pin here that allowed rotation and equalization. It really allowed the platform to move in the ways that it always had been, but without getting hung up and caught on the face of the dam, which had been happening from time to time. In general, what we're doing is we're taking challenging designs and design challenges and addressing those issues with tools that fit the need, right? So we're talking about fatigue that represents 80% of failures, but is something that a lot of times lives outside of prescriptive code and that owners and operators don't always understand very well. Specialized software tools are dangerous in that garbage in means garbage out. So you need somebody working on these who understands what the limitations are and how to use the tool effectively. And we're looking at not just stress, but also buckling and harmonic resonance and nonlinear effects, both geometric and material. We'll do cumulative fatigue analysis and look at specific components like this here. We were modifying a shiv design to fit what the contractor needed. Here we're talking about a large stretcher system where we were able to install strain gauges and compare the strain gauges to actual finite element analysis that we had done. We saw a great, within a few percent level of agreement between our prediction, and then to come up with what we predicted would be the damage, the fatigue damage that was occurring to this machine. So the red bars here are the fatigue damage, and the blue is telling you how many stretches they do at that load. And so over here on the right where the loads are high, they're not doing very many stretches, but they're doing most of their fatigue damage. And so we were able to help our client improve their operations, watch for and interrupt pulls that were problematic, and just develop a machine management system that was robust and allowed them to really understand the kind of fatigue life they might expect from their machine. Lastly, we've spent time on unusual structures, large art pieces, Seattle Museum on the left, a local ball field in Spokane here on the right, and we did finite element analysis of this design. We met with the artist and were able to help him tweak his design. There's a hidden piece of 3/4 inch thick plate running through the center of this that we were able to hide in the artistic elements that gave it the rigidity it needed so that he wasn't facing a failed art piece in a couple of years after a large windstorm. And you can see an analysis result. We've also helped out with spiral stairs, looking at them from a harmonic vibration standpoint as well as a stress standpoint, identifying areas that needed thickening and really validating what is a beautiful part of the structural design, but also a high-risk part if it's not understood correctly. So you can just see we were able to picture what the vibrational modes were of this platform and understand at what frequency they would occur. And then lastly, just another art piece, a very large butterfly, and sorting out how to support and suspend this thing and counterspring it and allow it the accommodation for high loads that is needed to prevent shock that causes premature failure. We really identified in stormy weather that this thing was seeing pretty high loads, especially loads associated with sudden changes in direction which cause a twist of the butterfly, and there was no allowance at the center there for the twist that rotates over, and you can kind of see that twist right here in slow motion as it boom suddenly goes to the side. And so in our redesign, we're addressing that and creating the ability for it to absorb shock in that direction and reduce the overall stresses. This is a picture of the mechanism that we've developed. Obviously, you're not going to understand it in 30 seconds of looking at it, but the point is we've come up with a maintainable system utilizing pre-designed torsion axles that would go like on a boat trailer, and use them in a unique way combined with fully custom designs that allow our client to have a safer installation that's going to last far longer.
And just in conclusion here, again, we appreciate your time today. I just want to emphasize the multidisciplinary approach that Kaufman has and can offer. RFP teaming, Chloe gave the example of Spada Lake, but we do provide pre-bid award engineering services where it makes sense and where it strengthens the team's proposal and approach. Let's see here. Other non-industrial services at Kaufman: fire protection, commissioning, survey. We do a lot of work with our survey group. Let's see here.
Our big point here is that you take away from this an understanding that we're ready to support you when you're pursuing work. We're ready to support you when you have a problem inside that's making you feel uncomfortable and like you want a second opinion or perhaps are required to have one by your contract. And we can join up with you once construction is going on a project. So it's all through it. You can see that this is not theoretical, but something that we have lived for years. And we're excited to support you, and thank you so much for your time.